Okay, well I got it fired up and it's been running for a couple hours just to check surface temperatures, things like that. As you can see, I haven't remelted the powder, it hasn't gotten sticky or anything, so as soon as powder gets melted again, it loses its gloss and you can see the reflection there as soon as powder melts. So the installation was a success. It's not going to remelt the powder. Our target temp's 1525, and we're at 1526 on a 1525 set point. And I actually have parts in there. I got a couple parts in there cooking. I'm not going to leave that open for too long. You lose a ton of heat every time you open the door. So you lose a gob of heat, and it climbs back up quick. But you do lose a lot of heat every time you open and close the door. Our fan is working nicely. The air coming out is just warm. I'm not going to say it's hot, but underneath I can feel the SCR or the SSR cooling hole. I can feel it pulling air in there, so that's good. We know our SSR is getting nice and cooled. And let me cut the camera. I'll open it up and I'll show you how I made the connections for the element inside. I used some porcelain insulators and some porcelain connecting blocks. So I want to show you what's going on in there. So let me take that screw out and I'll bring you right back, and I'm going to leave it running while I'm doing it. And I was going to show you my connections for the element. I've got 2 nickel wires. Right, let me see if I can hold the camera in and get a pointer. Okay, got 2 nickel wires right here. Got a porcelain block right here with 2 little copper bussings in there, and then that goes straight to the element. And then there's 2 porcelain tubes passing through, and you might be able to see a hint of glow. So that's the hot spot. You know, I'm going to take my little infrared temp, and so we're right at 200 on those connections right there. And then the porcelain tubes coming up on 300. So that's a real hot spot right there, where the wire has to exit and turn into that heating element. But I wanted it enclosed, so that's what I did. And I think what I'm going to do is, you can see down there, you can probably see those pencil lines. I think I'm going to cut some more air holes just below those connections, because remember, underneath the SSR, I've got a breathing port under there, and so when the fan's running here, we're drawing air across that SSR, and there's no reason why we couldn't draw a little more air across those connections there. So I don't see the harm in that. And our surface temperatures are running about 100.5 out here. So 170. Just warm to the touch. You know, it's not unbearable. Front door, 100.5. Side, 160. The side where the air cooled always runs a little lower, which is interesting. That's showing 147 over here. Back here we're kind of 125. So we're passing some air across here, and we're actually cooling this side of the skin. And yeah, this side of the oven's a little cooler. But it's nowhere near melting the powder. It's nowhere near what the other oven was, where you just burn the hell out of yourself if you even thought about touching it. I mean, this is mild enough where I wouldn't think twice about opening this up. I mean, it's pretty intense in there, but I still wouldn't think twice about opening it up with bare hands. You know, the other one, you wouldn't even be able to touch this handle. It would sear you the minute you touched it. So it's manageable, and with proper attire, your sleeves and your gloves, there's no reason why this oven's not workable. All right, so I'm pretty pleased with the installation results, and let's continue our test. Okay, so we just wound our Kanthal nichrome wire on a 3/8 rod. After everything relaxes and snaps back, you end up at right at 1/2 inch. So And then after you're done, you got to spread it all out, and you got to spread it out kind of evenly. And then we can test certain points and find out where we're going to get the ohms we're looking for, you know. But we need to stretch our element out, kind of spread it out a little bit as evenly as we can. And that's what our element looks like after we've stretched it all out. So if you have to stop, you know, when you're threading, you got your set. This stuff is 43 thousandths. I had it set up for 40 thousandths per rev. So you probably noticed I had to stop once, and that's where I got this little gap. But as soon as you stretch out, it just disappears with the rest of it. All right, so it's going to end up stretched out way more than that. But that's how you wind a nichrome wire. Okay, some people wanted to see what the Hotshot 360 can do, and you're probably asking, why the heck are we over at the drill press with a hardness tester? I've got a model 415C Rockwell C tester by PTC, and see it's just on a in a chuck on the drill press. Table is secure, and I just use a 1-2-3 block as kind of a little pallet. And before we use it, we're going to start off with a little calibration block that comes with the tool. And this is calibrated at 47.7 Rockwell C. And we're just going to, you know, double check the tool, make sure we're still in calibration from the last time we used it. And we're at 45, 46, 47. Yeah, we're right there. So we're calibrated. We're ready to use it. And what I've got here is a pair of little squares. And these have been milled. These are 01 tool steel. They've been milled, they've been monogrammed, they've had the pockets cut out of them, and they've had the fences cut. So these are ready to harden. But let's check them, you know, before we check them before we cook them. We're going to come down on a nice smooth milled surface. Finish is very important. So these things are coming in at Rockwell 12. So that's actually below C scale. C scale I think starts at 20. So these things are butter soft right now. That's why I was able to mill them so easily. And now it's time to go fire up the oven and get them hard. And we'll do two different tests. We'll do them as quenched, and then we'll temper them afterwards. Okay, first thing we're going to do is just prep the oven, get it ready for loading parts. I'm just going to put a couple of my pegs in here. And this is what the little stainless steel rods look like after they've been through a few cycles. I've been using this oven already. So that's what the little stainless steel rods look like. We're just going to drop a couple pegs in the floor. Give us a place to stand parts up. And we're going to put our parts in. There goes Mr. Air Compressor. Hope you don't mind. So we're just going to lean our parts right into those little rods we put in. And we've been torturing this oven pretty good. Over the past week or so, we've melted some aluminum, hardened some parts. We've actually used it to anneal some parts that still needed some machine work. So we've given it the torture test. Okay, everything's leaning up against those rods. I'll try to show you a little bit closer there. So everything's kind of tilted in there so that the only contact is kind of one little line up against the bricks, but the bricks generate a ton of heat. They really put out a lot of heat, and they really hold it really well. That's why it works so well for tempering and for annealing too. For annealing, just bring it up to critical temperature, let it soak a little while, and then just shut the oven down and leave the door closed and just let the oven cool by itself. And it takes the bricks hold the heat, and it really takes a good 12 to 14 hours to come down so that your parts are nice and soft when they come back out. So anyways, let's fire this thing up, and I'll show you how fast it ramps up. My initial tests. My initial tests were about 20 minutes to a full temperature rise and then 30 minutes to stabilize. Pretty typical that you overshoot your temperature on the way up. These little parts make critical temperature no problem, but we're going to go to 1500 degrees Fahrenheit and soak for a little while. Oops, it's like your alarm clock at home. You always go way past it. Okay, we got a 1500 set point, and I'll show you how how fast it ramps up here after that quits blinking. There we go. So there's your temp rise. It shows how fast it's coming up. Maybe get you in on that a little closer. And that's just the old crappy controller that came with my old oven. I've got new controllers on their way, and those were bought from Marshall Wolf Automation. My SSRs and my temperature controllers are all coming from Marshall Wolf. I wanted to make sure I got a year's warranty with everything from a reputable dealer. I wasn't going to go eBay cheapy on the controls. So I want to be able to offer a warranty, and if I'm going to offer the warranty, I got to buy it from someone that offers me a warranty. So that's how it works. Anyways, I'll bring you back in about 20 minutes when this thing stabilizes, 20-30 minutes after it stabilizes, and then we'll quench some parts. Okay, we're on temp. It's 32 minutes later, and my parts have had a good time to saturate. We are wearing protective gear. We are wearing welding gloves and welding sleeves. Getting burned by this stuff is zero fun. And then we've got a long handle pair of pliers here, custom made. Look at that. Okay, and now we're one hand operation, just a thumb. We got a door open, and we can get in and get a hold of a square, close it up, say we're red hot, and we're just going down in oil. And it's smoky and it's stinky, and I just give them about a 30 count in the oil. My oil is currently preheated about 100 degrees. So you don't want to shock your parts and hit them with really, really cold oil, especially if it's cold out. Just heat up a block or something in the oven and drop it in the oil to preheat your oil. Just a piece of scrap, whatever. But we want to quench these for about 30 seconds. And then they come out looking black and scaly and ugly, but we've got something to go check. Red hot. And down in the oil immediately. And do this in a well ventilated area where the smoke, don't try to do this down in your basement or anything. Do this where you've got some fresh air. I got 2 doors and a couple windows open here. Alright. So that's gonna stay in oil for a 30 count again. Or more. And my quenching oil probably is due to be replaced. It's getting pretty black over the years. This is a Quenchall. This is a 12-second formula. I've got 2 different ones. I've got a 12-second and a 27-second. I don't know where they come up with these numbers, but what it is what it is. So there you have it. But we're going to go take these over to the hardness tester before we temper, just for giggles, you know, and see what... and see how hard they really got, and then we'll temper them down and get them down to a usable hardness, because right now they're pretty damn hard. If I remember right, we're going to be low 60s with these things, so they're thin enough and small enough, and being that hard, if you drop them, there's a chance they will shatter and crack and break. So they're just kind of glass hard right now. Okay, so we finish up that last one, and I'll bring you back, and we'll meet you over by the hardness tester. Okay, I know a lot of you guys want to see inside of that thing, so with it on temp, so I'm just going to go ahead and open it up. Let's have a peek in there really quick before it melts the camera, because I got it pretty close. There's the inside of the oven there with my pegs. You can see my thermocouple up top, and that's the oven. All right. Okay, we're back from the hardening oven, and they took a trip to the sink, and you can see they got a little bit of polish. I cleaned all the scale off of them, washed them in the sink, and then ran them over a diamond card just to knock the high spots off. And now we've got a reasonably flat surface here. We can actually test them for hardness as quenched. And we're going to see where we're at. All right, so yeah, we're up 65 Rockwell. That sucker's hard. And then we're going to do this one. Same thing, that's about 64, so 1 point off. And we're going to go back to our test block. This is the end of the process, so we're going to go back to our test block. And this was 40, what was this one? Oh yeah, 47 Rockwell. And here we go. There it is, 47. Okay, so that's as hardened and as quenched. So now we need to get them soft. My target's between 58 or 56 and 58 on these little guys. When they're it's only an 1/8 inch thick, and if they were to drop and they landed wrong, there's a good chance it would snap and break. So there's a lot of stresses in this part, so they need to be tempered. Now I did this just to show you how hard they get. In the real world, what I do is I heat treat, I quench in oil, and then while the parts are still hot, I get them in the oven at tempering temperature. So that's kind of where you're at with it. You don't let them completely cool the way I've done here. So this was just for demonstration purposes. All right, so let's go get them tempered and see how soft we can get them. Right now we're about 64, 65 Rockwell C. All right, so our squares are back from tempering. You can see that kind of that golden color on the polish spots there, where we kind of brought them up to straw. We cooked them for 375 for an hour. So we're just going to do a quick check. We're still in the same calibration as last time. I haven't touched the gauge. Same setup. And what are we, 58? So we brought it down 5, 6, we brought it down 7 points. So we're at 58 Rockwell. And here, let's check the other one. Here we go. And 58 Rockwell. Very good. You start seeing more consistent numbers after you temper them, because tempering kind of relaxes the part. All your numbers start coming in. When you're heating, quenching, and just dropping parts in oil, any little bit of air moving over the part makes a difference. The temperature of oil makes a difference. Everything matters when you're doing the heat treat process. So you get numbers kind of all over the place. When they stabilize is after you temper them. That's when your numbers really start to come in and you start getting nice even numbers. So that's how we accomplish that. All right, guys, that's one use for the Hot Shot 360. Thanks for watching.